Hello, this video is on lesson 2-1. Starts on page 17, and we covered this September 6 through 7. Okay, so the learning targets here is we write equations in two variables to represent relationships between quantities, and graph equations on coordinate axes with labels and scales. Okay, Roy recently won a trivia contest. The prize was a 5-day trip to New York City, including a round-trip airplane ticket and $3,000 in cash. The money will pay the cost of a hotel room, meals, entertainment, and incidentals. To prepare for his trip, Roy gathered this information. A hotel room in New York City costs $310 per night, and the trip includes staying 5 nights. A taxi between New York City and LaGuardia Airport will cost $45 each way. Roy must set aside the cash required to pay for his hotel room and for taxi service to and from the airport. Once he has done this, Roy can begin to make plans to enjoy the city with his remaining prize funds. Okay, so there's a lot of information to take into here. Let's go ahead and highlight some few things. Roy has $3,000 in cash. And whenever you travel to a city, there's two very important things that you want to pay for. One of those things is a place to stay. Since you're staying 5 nights, you want to sleep somewhere for those 5 days. And also, transportation is very important. Since you're arriving at the airport, you need some way to get from the airport to the hotel. So it says that it costs $310 per night, and a taxi from New York City to LaGuardia Airport, or the other way around, is $45 each way. Alright, let's take a look at number 1. How much money will Roy have available to spend on performances, meals, and any other expenses that might arise after paying for his hotel and taxis? Show your work. So imagine that you are the one who won the 5-day trip. You have $3,000 in your hands to visit New York City. So the first thing you want to do is find out how much is a hotel going to cost you for 5 days, and how much is a taxi going to cost you for a round trip. So 310 is the cost for 1 day. For 5 days, you have to multiply 310 times 5. Let's figure out what that is going to be. 310 times 5 is 1550. Now you want to be able to go from the airport to the hotel, which is $45, but whenever your trip ends, you want to go from the hotel to the airport. So you have to multiply 45 times 2 for a round trip, and that is going to give you 90. So if we add these costs together, plus 90, hotel and taxi service will cost $1,640. So that is the total cost. Now you have $3,000. So out of those $3,000, after you pay for hotel and taxi, how much will you have left? Let's calculate that. 3,000 minus 1,640, and that leaves you with 1,360 left in your pocket. So once you're in New York City, you have $1,360 to spend on whatever you want. Let's continue on. During his trip to New York City, Roy wants to spend only his winnings from the contest. He wants to focus on 2 of his favorite pastimes: attending theater or musical performances, and dining in restaurants. After surfing the web, Roy determines the following facts. On average, a ticket for a performance in New York City cost $100. He will spend on average $40 per meal. Number 2. Roy wants to know how the purchase of each ticket affects his available money. Fill in the table below, plot the points on the grid. Okay, so let's highlight two pieces of important information. It costs $100 for one ticket and $40 per meal. Now you might be thinking $40 per meal, that's pretty expensive. Well, let's just say that he's going to a really expensive Italian restaurant where they import a lot of their foods. So that's why it costs $40. Okay. So in order to fill out this table, if Roy has $1,360 to spend at the beginning, if he buys 0 tickets, how much money is he going to have left? Well, he didn't spend anything, so he's going to have $1,360. But if he buys one ticket costs $100. After buying one ticket, how much will he have left? Well, he's going to have $100 less, so that's going to be $1,260. If Roy buys 2 tickets, he's going to have $200 less from his total, so $1,160. And as we keep buying more tickets, you can start to see that pattern that each time he buys a ticket, he has $100 less. And so this is how the table begins to be filled out. Now, notice that we jump from 5 to 8. So if he buys 8 tickets, it's going to cost $800. And so he's going to have $560 left. 10 tickets, it's going to cost $1,000. So he's going to have $360. And finally, 13 tickets is going to cost him $1,300, so that means that he has $60 left in his pocket. Okay, so remember from the function cycle, when you have your table, you want to all of these corresponding ticket values and money left available, these are ordered pairs. Remember, ordered pairs are basically XY coordinates that will help you graph the points on the grid. So here we have 0, 1360. So 1360 is somewhere around here. So that's how much money Roy has at the beginning without buying any tickets. And once he buys 13 tickets, he's going to have $60 left. So notice on this graph, it already conveniently gives you where it's going to cross the x-axis, because this is 11, 12, 13. He's going to have a little bit of money left over after 13 tickets, so that's why the x-intercept is not going to fall on a whole number, but it conveniently gives you where that mark is, where it crosses the x-axis. So your graph should look something like this. Okay, so number 3 basically asks, what type of function is this? Take a look at the function. This is a linear function. And there's something very important about linear functions. Why is a function a linear function? Well, because it has a constant rate of change. Number 4, explain how you determine the values for 8, 10, and 13. So notice from the table, you basically jump from 5 to 8, and then 8 to 10, and then to 13. So you skip some values in between. So it's basically the answer to this question is going to vary. So I'll just leave it up to you to explain what is your method for finding those ticket values, or the money he has left over after he buys 8, 10, 13 tickets. Number 5, write a function m of t that represents the amount of money that Roy has left after purchasing t tickets. Alright, so again, the function cycle is going to help you find the equation. So let me just recap over the function cycle. The function cycle, you start with your function. From your function, you can create a table. From the table, you can get your ordered pairs. From the ordered pairs, you can graph the function. And from the graph, you have to use the slope formula and the point slope formula in order to get back to the original function. So this is similar to the water cycle. So water falls from the clouds, the water collects into pools, and then it forms into rivers, and then it ends up in the sea. And then the water evaporates, and then it goes back into clouds. So similar to the water cycle, the function cycle works in the same way. Okay, so to write a function m of t, now don't let m of t confuse you. There are so many different ways to represent a function, and basically whenever you see f of x, this is a title. This is a title that represents a function. So it's like Mr. or Mrs. or Sir. There are different titles, so one different way to represent a function is m of t. So m of t is just basically the title for saying that you have a function. So there are many different names or many different ways to represent a function. So in order to find the function, the equation, let's go ahead and take two ordered pairs. Now we want to make it easy for ourselves. We want to use the one that has 0 and 1. So we'll take 0, 1360, and 1 and 1260. So our ordered pairs are 0, 1360, and 1, 1260. Okay, so those are the two ordered pairs. Now, from those ordered pairs, we want to label the first one x1, y1, and x2, y2. What this allows us to do is, we don't need to graph this once we have our ordered pairs. We can go to the slope formula in order to find the slope. So the slope formula, remember, is y2 minus y1 over x2 minus x1. And so basically y2 is 1260 minus y1, which is 1360, divided by 1 minus 0. If we simplify this, we get 1260 minus 1360, that's negative 100, divided by 1 minus 0, which is 1. And so my slope is negative 100. Okay, negative 100 is just a number. This is not an equation. So in order to get our equation, once we have the slope, we have to use the point slope formula. And the point slope formula is y minus y1 equals mx minus x1. M stands for slope. So remember, slope is negative 100. So we have negative 100 x. Now you can use any ordered pair x1 to plug in for x1, y1. So going back to our table, it does not matter which ordered pair you use for x1 and y1, you're still gonna get the same answer. So, but I like to keep it simple. So we're going to use 0, 1300. So x1 is 0 and y1 is going to be 1360. So we have y minus 1360 equals negative 100 x minus 0. Okay, so now we just go back to the fundamentals. We have to distribute this negative 100 inside the parentheses, so we have negative 100x, and negative 100 times 0 is basically 0, so we have nothing else. We have y minus 1360, and finally we want to go ahead and solve for y, so we have to add 1360 to each side, and so what we get is y is equal to negative 100x plus 1360. Here is our equation, and that is the answer to number 5. Now, we want to use this notation here to keep our answer consistent. So the final answer is m of t is equal to negative 100. Since we're using the variable t, it's going to be negative 100t plus 1360. Here is the final answer right there. Question number 6. Use mathematical terminology to explain what negative 100 and 1360 each represent in your function from the previous question. Okay, so here we have negative 100, and remember from your function cycle, since this is a linear equation, this is in the form of y equals mx plus b, where m is the slope, so negative 100 represents the slope, and 1360 represents the y-intercept. Now, it's very important not to just know that it's the slope and y-intercept. One of the important things about Springboard is that it asks you to explain what an answer represents in the situation. So the slope here is, if we put it in fraction forms, basically negative 100 over 1. Now, since this is a slope, this is the rise over run. Now, what does the slope represent in this situation? Well, let's go back to our graph. When we talk about rise, that means that we're moving along the y-axis. You're either going up or you're going down. And notice the units here for the y-axis. Money available. So instead of writing rise, I'm going to write money available. Money available. Now, for run, you're running along the x-axis, so, and the units for the x-axis are tickets. So instead of writing run, I'm going to replace it with tickets. And so this setup right here is going to give you what the slope represents in the real world situation. So if we read this, the slope, and actually let me type this out. The slope represents the money available per ticket bought. So that gives us what the slope represents in the real world situation. The slope represents the money available per ticket bought. Okay, and finally the y-intercept. You also want to put that into words that makes sense. So looking at our y-intercept, here we see that 1360 represents how much money you have, and 0 represents the number of tickets that you bought. So when Roy buys 0 tickets, he has $1,360. So that is what the Y-intercept represents in the given situation. Okay, so that was really important to answer number 6. Okay, number 7. Roy wonders how his meal cost will affect his spending money. Write a function d of m that represents the amount of money Roy has left after purchasing m number of meals. Okay, so this time we're not looking at tickets anymore. We're looking at meals, and remember, meals cost $40 per meal. So it is important to take into account how much a meal costs, and this time we're using the function notation d of m, where m stands for the number of meals and d probably stands for dollars. Okay, now notice we don't have a table to set up our equation, but what we can do is look at how we set up the previous equation for tickets. So the equation for tickets, which was m of t, is equal to negative 100t plus 1360. Now, remember, 1360 represents the amount of money Roy has to spend. And so, if we're just focusing on meals, Roy is still going to have $1,360 to spend if he hasn't bought anything yet. And notice here we have negative 100t, where t stands for the number of tickets, and 100 minus 100 represents that we're taking $100 for every ticket that he buys. So the same idea is basically going on in order to create this function. We're taking $40 away for each meal that Roy buys. And this is how we easily set up the equation for the number of meals that Roy is going to buy and how much money he has left. Okay, so we can go ahead and graph this, where 1360 is going to be the y-intercept, and negative 40m is going to be our slope, and we don't know exactly where this line is going to cross the x-axis. So let's take a look at number 8. Well, what kind of function is d of m? Well, looking at this is basically in the form of y equals mx plus b, where b is 1360 and m is negative 40. So this, again, we have a linear function. Question number 9. What is the rate of change for d of m including units? So just as we answered question number 6, where we took the slope and wrote rise over run, not in terms of the units that it gives us in this situation. So again, rate of change is basically slope, which is rise over run. So there's many different words for slope. You can call it rate of change in y or change in x. Alright, so rise basically stands for the going along the y-axis, which is again here money left. So instead of writing rise, we have money left. And then run is going to be running across the x-axis, which stands for meals. And so it's going to be money left per meal. And so if we write this out, the rate of change represents the money left per meal bought. There we go. Okay, now what it asks is, are all the values for M, question number 10, are all the values for M on your graph valid in this situation, given that M represents the number of meals that Roy can buy? Explain. The guiding question here is, up to what number of meals can Roy afford? So we're talking about Roy. How many meals can Roy buy if he has $1,360 and each meal costs $40? Well, you basically take 1360 divided by 40, and let's go ahead and calculate that. 1360 divided by 40, and we're lucky here, it actually comes out to a whole number. We have 34 meals that Roy can buy. So if he buys exactly 34 meals, Roy's gonna spend all his money and he's not gonna have any left over. So now we can go ahead and find where my x-intercept is gonna be at, because at 34 meals, which is somewhere around here, he's gonna have no money left over. So this point is no money left over. It's going to represent 34 meals with no money left over. And so now we have our 2 points, and that is the graph right there. Okay, so I think questions 11 to 14 are very important, because it basically ask questions about the function cycle. Question number 11, what do the x and y intercepts of your graph in item 7 represent? So here's our graph. We basically already talked about what this represents. X-intercept is when you buy 34 meals, you have 0 money left over. Here, the ordered pair, the xy coordinate is 0, 1360. 1360 is the amount of money Roy has at the beginning to spend, and 0 represents the number of meals that he has bought. So he's bought 0 meals, so that means he has $1,360 in his pocket. If you know the coordinates of 2 points on the graph of a linear function, how can you determine the function's rate of change? Remember, rate of change is basically the same as slope, and this again goes directly from your function cycle. If you have 2 ordered pairs, you go from those 2 ordered pairs, and we used the slope formula to find our slope. So that basically answers that question, number 12. 13. What is the relationship between the rate of change of a linear function and the slope of its graph? Well, rate of change and the slope are basically the same thing. They're just 2 different ways of naming the same thing. Number 14. Using your answers to items 12 and 13, explain how to write the equation of a line when you are given the coordinates of 2 points on a line. Again, that's directly from the function cycle. That's basically what we did here. We took these 2 ordered pairs, we plugged them into the slope formula. Now the slope formula only gives you a slope. It's only a number, not an equation. So once you have the slope, you have to go to the point slope formula, where you plug in the slope. You take any x1, y1, you take any ordered pair from your table, plug it into the point slope formula. Do a little bit of algebra, distributing, solving for y, and then you get your equation, your function. So I can't stress enough that the function cycle is something we're going to use repeatedly. So you must know all the steps that go into from going to an equation, to going from a function to the table, to an ordered pair, to a graph, and from the ordered pairs, go to the slope using the slope formula, point slope formula, in order to go back to your function. So it's just a cycle that keeps going all around and round and round. Okay, so that basically goes through the main points of lesson 2-1. Thank you for watching.